I'm Anil Kumar, back with some more questions from Nelson. This time it is question number 7, page 440. Well, I can't blame students to request me for these questions, since most of the test papers have direct questions from the book itself. In a way, it is unfortunate. Well, my advice to my students is that look into the reference questions, get prepared for the university. Of course, one idea is to get good marks in your school test also, but get prepared for the university. Well, these questions are, I will rate them very simple, and you will see how simple they are with the help of this example. So we are reviewing Unit 7, question 7, page 440. Determine whether each of the following is a trigonometric equation or a trigonometric identity. First, all of them are trigonometric equations, right? You should understand the difference between the two. Whenever we write equal to sign and we have trigonometric expressions on both the sides, it becomes automatically a trigonometric equation, right? So all of them are trigonometric equations. So that is the first answer. Now the second part is, which one of these are trigonometric identities? Now, for them to be trigonometric identities, they should be true for all values in the domain of the function. That is the criteria. So let's begin with the very first one, which is tan 2x equals to 2 sine x cos x divided by 1 minus 2 sine square x. It is direct application of your double angle formulas. 2 sine x cos x is sine 2x, right? And 1 minus 2 sine square x is cos 2x. And of course, when you divide sine 2x by cos 2x, you get the right side, and therefore this happens to be a trigonometric identity. So let me write TI here. The next one here is secant square x minus tan square x equals to cos. Now, we could do Pythagorean identity and work it out. Secant square x minus tan square x is what we know. But let me do it the other way, a long way. We know it is not an identity, but it is an equation, of course. So secant square x could be written as 1 over cos square x, correct? Minus tan square x is sine square x over cos square x. So we have started with the left side. Okay, so we started with the left side. And what we have here is 1 minus cos square x in the numerator, which is cos square x, correct? And in the denominator we have cos square x, which is 1, and we know this is cos x here. We know cos x could be any value. It is 1 only for few values, right? For example, it is 1 for 0, 2 pi and multiples of 2 pi, correct? Not for all, and therefore this is an equation, not an identity, right? So I'll write not trigonometric identity, correct? Now this one is cosecant square x minus cotangent square x equals to sine square x plus cos square x. Okay, now sine square x plus cos square x is 1. On the left side, let us see what it is. Cosecant square x, well, if you know Pythagorean trigonometric identities, we have a straight answer here. But I'm not going there. I could have just said yes it is, but we'll write cosecant square x is 1 over sine square x minus cot square x is cos square x over sine square x, correct? So we have 1 minus cos square x, which gives us sine square x, correct? So we have sine square x over sine square x, which is indeed equal to 1. And the right side is also 1, which is sine square x plus cos square x, right? So we get these as an identity. So I'll write trigonometric identity for this particular case. Here we have tan square x equals to 1. Well, tan has a range of all the values. 1 will be one of them. So this is not a trigonometric identity, correct? So that is how you can actually solve this question. I hope that helps. Thank you and all the best.